talking about the proportional unit, lesson 5, representing proportional relationships. The homework that goes along with this is listed here. We are on page 17 in your note packet. I believe it's 17. Find this page. Pause if you need to. All right. In class, I'm going to be giving you a piece of paper that is going to have all of these proportional relationship ideas on it. But these are things that you need to know. A proportional relationship. Two quantities vary directly with one another. Direct variation and proportional, same thing. They can be represented in several ways. Y equals Kx, where K is the constant of proportionality or unit rate. We've also talked about the fact that K is Y over X. You can think about this. If we've got Y equals Kx, I can divide both sides by X, and I'll get K is Y over X. If you have a graph, it needs to be a straight line and it needs to go through the origin. So if you look at a diagram and it is a straight line through the origin, then it is proportional. A set of data or ordered pairs that show equivalent ratios. Does K equal Y over X? If it's the same for every ordered pair, then it is proportional. And a verbal relationship that says it's directly proportional. All right. A car technician took a car on 4 test drives. For each drive, the technician recorded the miles driven and the amount of gas used. Does the data in the table represent a proportional relationship? Well, in a table, X is always going to be listed first. So we need to say, is K the same for every ordered pair here? 100, 4. Is that the same as 50 over 2? Is that the same as 25 over 1? Is that the same as 12 over 0.5? This will be 25 miles per hour, or I'm sorry, miles per gallon. This is 50 miles per gallon. 25 miles per gallon, I'm sorry. This is 25 miles per hour. If you divide 12 by 0.5, you get 24 miles per gallon. All the rest are 24 miles per gallon. So is this proportional? No. If it didn't have this bottom one, it would be. But it is not proportional. Because the constant of variation is not the same. All right, let's take a look at these. Do these points represent a proportional relationship? Well, aren't ordered pairs always x, y? So we need to see straight up. K is y over x. Let's see if it's the same for every ordered pair. 7.8 over 3. Is that the same as 15.6 over 6? Is that the same as 18.2 divided by 7? If you divide these, you will get 2.6 for every one of them. Just use a calculator. So is it proportional? Yes. And if we connected these by a straight line, it would be a straight line through the origin. Show that the ordered pairs in the table represent a proportional relationship. Then write an equation to represent the proportional relationship. All right, y equals kx. In order to write an equation, we need to find k. Well, we know that k is y over x. So, let's see. 7 divided by 2.5. 8.4 divided by 3.0. 9.8 divided by 3.5, and 11.2 divided by 4. If you divide those, you are going to get 2.8 for every single one. So K is 2.8. So our equation is y equals 2.8x. It is proportional, and this is our equation. K is the constant of proportionality. Okay. The graph below shows the cost of buying pairs at a pharmacy. What does the point 1, 2 on the graph represent? How could you use that point to help you write an equation to represent If I go to the point 1, 2, that's right there. X is 1 pound, and this is $2. So, doesn't that give us our unit price? It is $2 per pound. Because look, if I go to 2 pounds, it's $4. 3 pounds, it's $6. The unit rate is always located at 1. 1 unit rate. 1 K. K and unit rate are the same. It is always on a proportional graph located at X is 1. This is $2 per pound. So our equation would be Y equals $2 per pound, 2X. Y equals KX. Remember, we are always using that equation for proportional relationships. And K is located at 1. All right. A scientist measured the total distance in feet a grasshopper traveled in 3 jumps. Is the relationship between the jumps and the distance proportional? If so, what is the grasshopper's unit rate? So, I'm going to draw a graph. Here's our graph. 0, 0. 1 jump is 1.5 feet. 2 jumps is 3 feet. 3 jumps is 4.5 feet. Does this form a straight line through the origin? So yes, it is proportional. And what is its unit rate? It's K, or unit rate, is what? 1.5 feet per jump. 1.5 feet per jump. If I wanted to write an equation, it would be Y equals 1.5x, because that is our K